In this video we will create a two-dimensional axisymmetric De Laval nozzle, and later on we will also mesh it before we import it to ANSYS Fluent. The De Laval nozzle is composed of two different sections. We have one converging section and one diverging section. In the middle we have a throat in which the sonic velocity will be reached for the fluid flow, and before the throat we have a high pressure region with low velocity, and after the throat we have a low pressure region with high velocity. So basically what happens is that after the throat the fluid flow will expand, the gases will expand, and at the same time they will accelerate to supersonic speeds. And one of the main purposes here is to actually eject the gases parallel to the axis. So we want all of the kinetic energy to be directed in the axial direction of this nozzle. So how do we actually construct this kind of nozzle in ANSYS Fluent? Let's have a look at that. To begin with nozzle creation, we just simply drag and drop fluid flow analysis system, and then we get this tree of geometry mesh setup solution and so forth. I have named this project De Laval Nozzle, and then to begin with the geometry creation I right click on geometry and go into edit geometry in design modeler. We could also use space claim, but this video is for the design modeler. So if we want to create this Laval nozzle, this 2D Laval nozzle, we begin by hitting the XY plane, and then we generate a sketch. So now we have a sketch in the XY plane. We can look at the XY plane like so, and we go directly into the sketching tab. And the first thing to do here is we go into settings, and then we go into grid, show in 2D, and use the snap function. You will see what the snap function does later. And now I want to change the grid spacing. Now it's 5 meters. It's a bit too large for a nozzle, so I put it at 0.1 meters. And then we can change the minor steps per major to 10. So if we scroll in using the mouse scroll wheel here, we go into 0.1 meters here, you see that the solid lines represents the major grid spacing and the dotted lines is the minor grid spacing. So okay, let's go back to draw, and now I will draw this out just with lines, and this nozzle will be located with its axis aligned with the x-axis here, so the horizontal x-axis. So begin by creating the inlet of the nozzle, and let's pick, let's say it's 3 centimeters in radius, and then you see now this H here that comes up means that this line is truly horizontal. But we don't want it to be horizontal. Let's have a converging section of 3 centimeters wide, and then just, okay, let's create a diverging section of equal length. Now we create the nozzle outlet, and you see also here the V here represents that we have a vertical line. And everything snaps, so if I put the mouse in between here, it tries to snap to either of these node positions. So that's the snap function. Okay, so finally let's go and create this axis for the nozzle. So okay, we're going back into modeling. We have highlighted the sketch, and you see that it forms a closed surface. Now we can go into concept and create surface from sketches. The sketch is marked, and we have that as base object, and we just hit apply. And now you see that we have a small lightning next to this surface sketch object that has been created, and that means that it's not updated, so we need to hit the generate button in order to update it. So now you can see the surface that we have created, and if you click the scroll wheel on the mouse button, we can change the viewing angle here, and you see that this is a two-dimensional shape created in the XY plane. Okay, let's go back here. So if we want to look at this in a three-dimensional way, we can actually create this three-dimensional shape right away, just to have a look at it. If we mark the sketch and then we use revolve, so this means that we will revolve it around some axis. And for geometry we choose sketch 1, and for axis it's not selected, so we click this and then we pick the x-axis, apply, and then you see the lightning again, means that we need to hit the generate. So okay, so this is the three-dimensional shape of the nozzle that we have created. But since we will do our analysis in Fluent in 2 dimensions, we don't need this, so this is just for visualization purposes. So let's remove it again. I hit the delete button and then, yeah, remove it, yes. So okay, if we want to make this a bit different now, let's assume that these lines are too sharp in this nozzle. So what we can do is we can, for instance, use arc by 3 points, and then if we mark these 2 points, and then you see that when the peel lights up, it indicates that we have the central point marked. So now we have created an arc in between these. We can go into modify and then trim away the lines that we created previously. Okay, so if we go back into modeling just quickly now, we see that we have this lightning now again. So it means that we need to hit generate in order to recreate the surface. We do that, and you can see now that we have a smooth curve for the converging section and diverging section. Okay, so normally perhaps we don't have the same size of the converging section as the diverging section, so we can do this once more. So let's draw these, we can call them construction lines once more. And then I will also create construction lines that are farther away. So they are 3 more centimeters here, longer. And by doing that we can, and let's modify first and trim away this one. So okay, now we can create the arc by 3 points once more. And the second arc we create from the outer construction lines. And then we go back into modify, and we can trim away the excess lines here. And you see that the trim tool actually removes not the entire line that has been lighted up here, but it removes until it reaches a crossing line. So we have to remove all these. Now we have a nice smooth converging section. Then let's remove the things that we don't need for the diverging section. So, and then we go back and we add the outlet here and the axis, like so. And then we can hit generate again to redraw the new surface. Okay, nice. Okay, we can just have a quick look on this sketch, and if we look at it in 3D. So geometry, sketch 1, and then the axis, we pick the x-axis again. So this is slightly different from the previous 3D shape. Okay, remove it again. Okay, we can see that we have some construction dots here. We can actually remove those. They will not affect anything, but it's nicer if we don't have them. Finally, if we wish to have the original shape, like this, then perhaps it's easier to create this using a set of nodal points that we can read. We can go into create point and use from coordinates file, and then we can read some points file in which we have created points ourselves, and then it will interpolate between those points to create a smooth curve. The points file looks like this. So all the text between the hashes is just comments. And in this case, this is the important information. We have the group number first, and then we have the node number in the group. These must be integers, and then we have the coordinates of the points or nodes. And I've created this in meters, so you see 0, 0, 0, and then 40 millimeters here, 40 millimeters. Okay, let's remove that. Yep. Okay, that concludes the geometry part of this tutorial. To open meshing, we just simply right-click and hit Edit. Then we come into the meshing tool of ANSYS. It looks like this. First, I like to right-click and then choose the view front here to look straight at the model. We can go into information about the model. We go into surface body here and look at the material. It's designated designed by geometry here to be solid. We can change that to fluid, since we will model fluid flow inside of this nozzle. Okay, so just right click on the mesh and hit the generate mesh, and now we get a very coarse initial mesh. So there are some things that we can do to improve this. The first thing that we can do is, if we right click and then take insert and go to phase meshing, we mark this by left clicking and then click down here and hit apply. So we mark the phase, and then we hit the update button, and you can see that now this mesh is actually structured. So this is very coarse. In order to make it less coarse, we can right click and have insert. We can change the sizing of the cells. Now I go into, let's try and mark the face first. And we can go by element size, and we see here that we have 4.7 millimeters as the default size, and let's put 2 millimeters. And hit the update. So now you see we have a much finer mesh. We also have another option. If we remove this by deleting it, we can go into insert, sizing, and then we go to edge instead of the face here. And we can mark the edges. Let's mark the inlet and the outlet. Apply. And then instead of taking the element size, we can take the number of divisions. And let's put 25 divisions here. Then we update. And now you can see that in the vertical direction we have much more cells than in the horizontal direction. So we can further possibly improve this. We can go into sizing and let's pick this part first and apply and go into number of divisions, and then let's pick 7. And we can right click and have sizing of the other part, apply, and also take number of divisions and put that to 15. And finally, let's have the sizing of the bottom edge, the axis here, and go into number of divisions. And we had 7 plus 15, so let's put 22 at the bottom. So let's update and have a look at that mesh. So now we have 25 cells on the inlet and the outlet, and we have 22 cells on the top and bottom edges. You can see that the cells are smaller and gradually grows in the axis direction, and then they shrink as they come closer to the other edge, the outlet. If we want to have a more uniform distribution, we can go into edge sizing and change the behavior from soft to hard. Trying to enforce the size here. And now you can see what happens also. Now the size of the elements in the horizontal direction is more uniform. However, the 25 divisions in the vertical direction did not seem to stick. So we also need to change that behavior from soft to hard. So what we have created now is a stretched mesh, and this can be useful because we have the gradients actually in the vertical direction in this nozzle rather than in the axial direction. And the benefit of doing something like this is that if we look at the statistics, we have 550 elements in this system, and we have saved a lot by having elongated elements in the axial direction. This may not be sufficient for the actual analysis, but I'm just showing you the means here. We may be forced to increase this number of elements substantially for the actual simulation later on. Okay, when we're finished with that, we just need to add some boundary conditions, and we do that by right-clicking. Make sure that you have edge selected here. Left-clicking first and then right-clicking, and then you create the named selection, and this will be inlet, and that will be recognized in Fluent as inlet then. And here left-click then right-click and create name selection outlet. And finally we create this axis, call it axis. all these names will be recognized. And if we take some other name, for instance, if we mark these two by control clicking and then right clicking, we could name these top wall, or we can name a nozzle wall. It doesn't matter. If it's not recognized by Fluent, it will default to wall. And if we don't name it at all, it will become a wall. But let's put it at nozzle wall. Okay, so that concludes the meshing part of this tutorial.